So now we're going to look at the distance formula. And the distance formula is used to calculate the distance between coordinates on a Cartesian grid without actually having to plot them. So d, the distance, equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So in our example, if A has the coordinates 3, 4 and B has the coordinates 10, 12, we want to calculate the length of AB. So let's connect A and B together because I happen to have them plotted, but you don't need to plot them to use the distance formula. What we're going to be doing with our formula is we're creating ourselves a right angle triangle. So if I draw in the base of that right angle triangle, that's the difference between my x coordinates, the x2 minus x1 part. And if I draw in the height of my triangle to make it into my right angle triangle, then that's the difference between my y coordinates, which is my y2 minus y1 all squared. So that means that my x1 and x2 are the 3, that's x1, and x2 is the 10 of my b coordinate, and my y1 is the 4 of my first coordinate A, and y2 is the 12 of coordinate B. And now I'm going to substitute them into my formula. So d equals the square root of x2, which is 10, minus x1, which is 3, all squared, plus y2, which is 12, take away 4, all squared. Now, if you're putting this into a calculator that doesn't have a square root button that will go over the top of everything, make sure that you put in brackets around everything that's underneath that square root sign when you're typing it in. So we end up with the square root of 7 squared plus 8 squared. And that gives us 49 plus 64, which gives us 113. And that's root 113 units. If the question doesn't ask you to round, then leave it as an exact value. So leave it as a third. Now, what happens about using the distance formula in 3 dimensions? Now, in 3 dimensions, instead of using just an x-axis and a y-axis, we actually are bringing in a 3rd dimension and for the height of our cuboid, and that's our z-axis. So if we were to have a look at how these axes would correspond to the cuboid that we've got there, we've got our x-axis, which is the length, we've got our y-axis, which is the depth, and then we've got our z-axis, which is the height of our cuboid. So instead of it being x2 minus x1 all squared plus y2 minus y1 all squared, in 3 dimensions, the formula is going to become the square root of x2 minus x1 all squared plus y2 minus y1 all squared plus z2 minus z1 all squared. So how do we get the coordinates? So if we imagine that A is the coordinate 0, 0, 0, so the origin of our axes, if we then draw those axes on, so let's use green, that's my z-axis, that's my x-axis, and that's my y-axis. That's x, y, and z. If I want to know what AF length is, then F, I need to work out what the coordinate of that point is. So to get to F, I'm going 6 units along my x-axis. I'm then going 2 units back for my y-axis, and then I'm going 3 units up for my z-axis. So the point F is going to be 6, 2, 3. So now I can substitute in to my distance formula. So I've got the difference of my x coordinates, which are 6 and 0. So 6 take away 0 squared. The difference in my y coordinates, which are 2 and 0. So 2 take away 0 all squared. And the difference in my z coordinates, which is 3 take away 0 all squared. And that gives me 6 squared plus 2 squared plus 3 squared, which gives me root 49. And that gives me 7. And because I've got a unit in centimetres, my answer is going to be 7 centimetres.